Hello everyone, hope you are all having a good day. My name is Aryavarthan Sharma. I am from semester 3 ICT department, Marwad University. And today I have made this video to talk about bandwidth and bitrate. So right now we are currently studying the subject called Introduction to Communication Engineering in semester 3. And in that there is this concept of bandwidth and bitrate which I am going to explain today. And we will also see a few of the problem statements related to bandwidth as well as bitrate. So let's move on. Okay, so what is bandwidth? Okay, bandwidth can be referred as the difference between the highest frequency and the lowest frequency of a signal. So whenever we are talking about whenever we are talking about bandwidth, it's of a composite sine signal. Okay. Now here I have also given you an image in which there is time domain decomposition of a composite signal. So this is a composite signal and it is decomposed into three sine waves. One sine wave is having the biggest frequency, higher frequency. Then there is the intermediate frequency and then there is the lower frequency. So this is decomposition in time domain. We will also be seeing how to decompose a composite sine signal into frequency domain as well in the further problem statements. Uh, let's move on further and see the problem statement one. So here we are given a periodic composite signal with a bandwidth of 200 Hz is composed of two sine waves. The first one has a frequency of 100 Hz with a maximum amplitude of 20 volt, and the second one has a maximum amplitude of 5 volt. Draw the bandwidth. Okay, so before I explain the solution to you, I would like to explain you the equation. So what they are saying is that we are given a periodic composite sine signal with a bandwidth of 2000 Hz. Okay, so let's see. Uh, I am going to explain you by drawing it. Hmm, okay. Okay. So we are given the bandwidth. We are given the lowest frequency, which is 100 Hz, having an amplitude of 20 volt, and the second sine wave has maximum amplitude of 5 volt. But we are not given at what frequency it is. So first we have to calculate the higher frequency. Now, how are we going to calculate? So first, as I have written here, calculate the bandwidth. So we are already given the bandwidth, which is 2000 Hz. So using the equation, we will be using this equation. Bandwidth is equal to highest frequency minus lowest frequency. Let's see. By using this equation, we can know that. Uh, let me see. Okay. So if the total given frequency is 2000 and the lowest frequency is 100, then our highest frequency will be 2000 plus 100, which will be 2100 hertz. 2100 hertz will be the highest frequency component in our composite sine signal. So first of all, let's understand the question. So it says that we are given two sine waves. One has an amplitude of, let me see again. Okay, one has an amplitude of 20 volt, 100 hertz. Okay, so this is our time axis. Okay, this is our voltage or amplitude, you can say. Y axis is amplitude or voltage. X axis is for time. Now let's draw the first wave, which is of 20 volt. And okay, so don't go on my drawing. I'm drawing with a mouse. I don't have that pen or anything. Okay, so let's see. Uh, yes. So this right here, it must be 20 volt. Okay, first sine wave is of 20 volt. And they are saying that we have also second sine wave, which is of 5 volt. So Let's draw that. I'm going to use another color. This is green. Uh, okay. I have not drawn much of it as my drawing is very bad, as you can see. But the amplitude for the second sine wave will be 5 volt. So we understood the question. Now let's see what it is asking us. Okay. Okay. Draw the bandwidth. So we are supposed to draw the bandwidth. Now you can't draw the bandwidth in time domain. Yes, we have tried to represent it, but whenever we are saying to represent the bandwidth, it's usually in the frequency domain. So I also set an example. Let's look at the examples. Exactly what we did. But here, for just an example, we are given three signals with 0 hertz, which is this DC sine wave at 15 volt, then 1 hertz, which is this sine wave at 10 volt, and 2 hertz, which is at 5 volt. So this is the time domain plot of that signal, of those three signals, and this is the frequency domain plot of the time domain, right, of this signal frequency domain plot. Now let's try how our frequency domain plot will look like, and let's see. So this is the frequency domain. Here, as we were given, the 100 hertz sine wave having 20 volt amplitude, and the highest frequency, which was 2100, having 5 volt amplitude. So the bandwidth would be highest minus lower frequency, which will be 2100 minus 100 will be 2000. So we solved this statement. Now let's move ahead and see the problem statement second. Okay, so here we are given which signal will be having a wider bandwidth, a sine wave with a frequency of 100 hertz or a sine wave with a frequency of 200 hertz. Okay, so let's clear this. Yeah, so here, unlike the first question, we are not given here a composite sine signal. So both the signals are different. Both signals are not same or not together or not modulated together. They both are different and they both are different sine waves of each frequency. So if we draw them, then they will be like this. We are not given any voltage, so just we will take everything. Let's say this is at 5 volt and 100 hertz, right? And then there is another sine wave of 200 hertz. Okay, so yeah. So we are given both the sine waves differently. It's not the same or they are not modulated together. So whenever we are talking about bandwidth, it's a range of frequencies. It's from the lower component to the highest component of the frequency. Whenever we are talking about a range bandwidth, it is a range of frequencies ranging from the lowest to the highest frequency. Now here we are given individual sine wave signals, and we are asked who will be having a wider bandwidth. So my answer would be that both in both the cases bandwidth would be same, that is zero, as there won't be any different frequency or a range of frequencies seen in both the signals. Now let's check what the solution says. Okay, so it says the same, that in this case bandwidth for both the signals will be same, that is zero. Okay, so I'll try to explain more about in detail. Okay, so let's say this is your y-axis and this is your x-axis. Okay. Now, whenever we are talking about a periodic composite signal, so it will be having distinct frequencies like this, then there is this, then there is this, then there is this, right? Now, in case of a non-periodic composite signal, it will be a range. It won't be discrete like this, then also, then there is this, then there is this. It will be continuous in time, not discrete. Whenever we are talking about non-periodic composite signal. And whenever it is bandwidth, so bandwidth is like, let's say the lowest component you have is 100 hertz. Okay, taking this example. Taking this example, both the sine waves. This is of 100 hertz, then this is of 200 hertz. We can't take this into consideration because this is not a composite signal. Both the signals are individual, so this representation that we did is wrong. So again, I am telling you, in both the cases, the bandwidth will be same, that is 0. Now let's know more about bitrate, I guess. Okay, yeah. Okay, so what is bitrate? The number of bits per second that can be transmitted along a digital network, or you can also say that the number of bits you are sending in 1 second can be known as your bit rate or data rate. Now let's see what. Okay, so I'll try and explain this image. In this image, we are given a digital signal. Okay, and here these are bits 1 0 1 1 0 0 0 1. Now let's assume that this is 1 second. The whole time is this is 1 second. Okay. Now count the bits 1 2 3 4 5 6 7 8. So in 1 second, there are 8 bits which are getting transmitted, right? So the speed will be, the bit rate will be 8 bits per second. Here the unit is bps, which means bit per second. Let's see the problem statement one. What is it asking? What is the bitrate for each of the following signal? A signal in which one bit lasts 0.001 second. So here we are given to find the bitrate. So for that there is a very simple formula, that is 1 upon bit duration. So how to calculate the bitrate? Okay, so in each the cases we will be saying that it's for only 1 second. The time period that we will be taking to calculate it will be 1 second. So 1 second divided by its bit duration. So bit rate will be 1 divided by 0.001, that is 1000 bps, which means that there will be 1000 bits sent per second, also known as 1 kbps. And in second question, we are given a signal in which one bit lasts 2 milliseconds. Then again, we will find the bitrate in the same way. 1 divided by 2 milliseconds, which will be 500 bits per second. And again, let's see the third question, which is a signal in which 10 bit lasts 20 microseconds. So here, first of all, we are dividing the 1 divided by bit duration, which is 20 millisecond. Again, we are dividing it by 10 because number of bits are more. And finally, we are having 500 kbps. Okay, so there is one more terminology that we use in while saying bitrate. One is we say uh, one is we say kbps. Okay, and then there is another terminology which says kbps. Now both has the different meaning. In both the cases, there is just the difference of b. In the first one, in this one, the small b represents bit, and in this one, the the greater b represents byte. Okay, so whenever we are whenever we are purchasing any internet pack, so it says that we are giving you, sir, we are giving you 60 Mbps, we are giving you this, we are giving you that. So if it is written that they are giving you 60 Mbps speed, transmission speed, so they are talking about this speed. And whenever you are downloading anything, it will be downloaded in bits. So you will be getting your speed dividing by 8, because 8 bits is equal to 1 byte. Let's move further ahead. Let's look at the problem number 2. A device is sending out data at the rate of 1000 bits per second. How long does it take to send out 10 bits? Okay, so in the first one, we had to calculate the bit rate. In the second question, we are already given the bit rate. We just have to calculate how much time does it take to have the number of bits. So in the first one, it says that how long does it take to send out 10 bits. Okay, so it's very simple. We are just going to divide 10 divided by 1000, which will be 0.01 seconds. In second case, it says that how long does it take to send out a single character, which is of 8 bits. So it's again easy. 8 divided by 1000, which will be 8 milliseconds. Okay, so let's look at the third question. How long does it take to send a file of 100,000 characters? So now it's given 100,000 characters. Each character consists of 8 bits. So we are going to multiply first 100,000 into 8, then divide it by 1000, which will be 800 seconds. So total time to send a file which consists of 100,000 characters will be 800 seconds. When the bit rate will be 1000. Okay. So thank you guys. That was it from my side. I hope that you liked. I hope that you liked my video and understand a few basic concepts of bandwidth and bitrate. If you have any further doubts, then you can comment down below as well. Thank you.